right, welcome to exponentials. We have officially left quadratics in the past, and we are into our last function. So just like this last unit, we're going to talk about the transformations of an exponential function. This is the standard form, and you'll notice a lot of the letters repeated. Okay? So a lot of their characteristics, their transformations are going to repeat. Let's start with the letter A. That letter A has several different types of transformations. Remember, we have a negative A, and then we just have an A value. But remember that A value, when it's greater than 1, it was a stretch. That still holds true here. Okay? Remember, our graph's going to get tall and skinny. When that A value was less than 1, but that A value was greater than 0, that's a shrink. Remember, that's short and wide. And we talked about numbers that are less than 1 but greater than 0 are fractions. What does that negative represent, though? That negative only means what? The negative is only a reflection. So anytime I see that negative sign, it's only a reflection. I'm going to skip the B for now, and I'll come back to it. Let's talk about H. Remember, our H value, the type of transformation is going to be a horizontal shift. That means we could be moving left or right. So remember, if we have a positive H, we're always thinking the opposite. We're headed to the left. And when we have a negative H, we're going to be headed to the right. That K value still represents a vertical shift. Remember, vertical means up or down. So if we have a positive K value, we're going to move up. And if we have a negative K value, we're going to move down. Your K value also has a special characteristic. It's this thing called an asymptote. An asymptote. We'll learn about asymptotes when we talk about characteristics here in the next couple of days. Your B value. Your B value is actually not a transformation. So let's write that down. It's not a transformation. It is not a transformation. It's a parent function. Okay. We talked about parent functions with quadratics. Well, my parent function changes with every exponential equation. We have to look for that parent function. Okay? That parent function is written as b to the x. Okay? That is your parent function, b to the x. Okay? And that b stands for base. Okay? So if my b value is greater than 1, I'm going to have something called a growth. And if my b value is less than 1 or greater than 0, remember, that's going to be a decay function. Now, a growth function looks like it's climbing up a hill, and a decay function looks like it's falling down a hill. So those are the basic transformations. one more thing that we could add to this a value while I'm thinking about it, we'll talk more about it with characteristics, but if there is no shifts, so left, right, or up, down, then it's your y-intercept. Okay, but only if and only if. Again, we'll talk about that characteristic when we get to our days of characteristics. Let's practice identifying some of these transformations. Okay, so the first thing we want to find is we want to find our parent function. Our parent function is 2 to the x. Okay, notice that the x is in the exponent spot. That's why it's called an exponential function. So that's our parent function. We have a base of 2. So if I have a base of 2, my base is greater than 1. So that's a growth. Again, that's not a transformation. That's just an excellent characteristic to be aware of. The transformation that we have here is we have up 7. In number 2, we have 3 to the x. That's the parent function. That 3, notice, is my base and it's bigger than 1, so I have a growth. Okay, but again, not a transformation, just a very important characteristic. So let's look at our transformations now. We have this negative, that's a reflection. We have plus 5 by the x, so we'll do the opposite, that's left 5. And then the minus 2 is down 2. Another example here, let's look at our parent function. 1/2 raised to the x. Again, that's the parent function. So that tells me my base is less than 1, so I'm going to have a decay function. Again, just an important characteristic. This 2 is bigger than 1, so we have a stretch. This is a minus 3, so we're going to the right. And the plus 12 tells us we're going up 12. Let's flip over and look at some more examples. All right, I'm going to do just one more example and a couple of examples on how to write the function. And then please check the blog and the remind on how I want you to submit the rest of the problems for accuracy, for some classwork checks. So let's look at number 1 here. We have a parent function of 1/3 to the x. So that's my parent. And that base is less than 1, so it's a decay. Remember, that's not a transformation. It's just a very important characteristic. Here we have a minus 2, so that's to the right 2. And then here we have plus 1, so that's up 1. That's just identifying the transformations. What if I ask you to write them? Well, if I ask you to write them, I'm going to start with a parent function. So that parent function is going to be 1/4 raised to the x. And I'm always going to put my base inside parentheses just in case something weird happens. It says to the right 1, so I'm going to put minus 1. And then it says up 1, so I'm going to say plus 1. And remember, since it says equation, I'm going to write y equals. So let's look at another one. My parent function is 3 to the x. 3 to the x. It's an equation, so I'm going to write y equals. It says right 2, so minus 2, and it says down 1, so I'm going to write down 1. Again, go ahead and check the blog for submission of the rest of these questions so I can get you an accuracy check. Happy studying!